Have you ever thought about what might be falling out of the sky? Besides the usual stuff like rain or meteors, because back on March 8th, 2024, a family down in Florida, they were just going about their day and bam, this thing crashes right through their roof. Turns out it was a piece of a, like, 5,800-pound cargo pallet that had been jettisoned from the International Space Station, tore through 2 floors, and then, just a few months later, June 2024, the ISS crew themselves, they had to suddenly shelter because a Russian satellite shattered nearby, debris everywhere. Yeah, these aren't just like a one-off freak accidents, and it's definitely not science fiction anymore. This is the real deal, the very real consequence of something called space junk. It's this tangible, growing threat right above our heads. Ever since Sputnik went up in, 1957, we've launched thousands and thousands of objects into space. And, well, let's just say we haven't been the tidiest tenants. We've made quite a mess. Okay, so let's really unpack this. In this deep dive, we're going to dig into what exactly space junk is, why it's become such a critical problem both up there in orbit and potentially right here on Earth, and also what kind of clever, maybe even surprising efforts are underway to try and clean up our orbital neighborhood. By the end, you should have a really clear picture of this unseen peril.
That's exactly right. And space junk, or space debris as it's often called, it's essentially any human-made stuff left floating in orbit. And like you said, it's not just big things like whole dead satellites that have, run out of fuel or power. It's also broken bits from things crashing into each other, pieces of machinery, discarded rocket stages, and even, believe it or not, tiny flecks of paint, just paint stripped off spacecraft, because space is, well, it's an incredibly harsh environment up there.
Yeah.
And the key thing to grasp is that, especially in the early decades of the space race, there just wasn't much thought, or really any plan sometimes, for what to do with things at the end of their life. They were just left.
Left up there. Wow. And when you say mess, how big are we talking? Like, how do you even start to quantify that? We hear about active satellites, sure, but what about all the other stuff? Is most of what's orbiting actually doing anything useful anymore?
That's a great question. And the scale is, well, it's pretty staggering, especially when you look beyond what we actively track. So you're right, we've got maybe around 2,000 active satellites doing their jobs, but compare that to roughly 3,000 dead ones, just inert, tumbling. Now, space agencies and military trackers, they actively monitor over 29,000 pieces of junk that are bigger than, say, a softball, things they can actually see with radar. But here's the kicker. Beyond those trackable objects, researchers estimate there could be more than 100 trillion untracked pieces.
Wait, 100 trillion?
Trillion, yes. And the vast majority of those are tiny, most less than a centimeter across. Little bits of metal, paint, frozen coolant.
100 trillion. That number's hard to get your head around. And a centimeter sounds really small. But you said even tiny bits are dangerous. Why is something that small such a huge deal?
It's all about the speed. That small size is incredibly deceptive because everything up there, regardless of how big or small it is absolutely screaming around the Earth.
Yeah.
We're talking speeds between 15,600 and maybe 18,000 miles per hour.
Miles per hour, not feet per second.
Miles per hour. To put that in perspective, that's up to 10 times the speed of a bullet fired from a gun. So yeah, even a minuscule fleck of paint, when it's moving that fast, packs an enormous punch. It has incredible kinetic energy.
So it's basically like a tiny, super fast cosmic bullet.
Yeah.
That's a terrifying thought. And how does all this stuff get created? Is it mostly just these old satellites dying off, like you mentioned?
That's part of it, but it's actually more complex. A lot of the initial debris did come from those early launches, big rocket bodies, entire spacecraft just left behind with no plan for disposal. But Holger Krag, who heads up space safety at the European Space Agency, ESA, he pointed out back in 2020 that the single biggest contributor now, or at least then, was actually explosions in orbit.
Explosions, like things blowing up deliberately.
Sometimes, but often not. A lot of these are caused by leftover fuel or batteries on board old spacecraft or rocket stages. They degrade, overheat, and just boom.
Yeah.
Think of it like a sort of unintended self-destruction, generating potentially thousands of new, smaller pieces of debris from one event. And then, of course, you have actual collisions. These are becoming more frequent. The average over the last couple of decades has been about 12 accidental fragmentations, as they call them, per year. And we also can't ignore the anti-satellite tests, ASAT tests.
Right, where countries intentionally destroy their own satellites.
Exactly. The U.S., China, India, they've all done it. And when you blow up a satellite, you instantly create a cloud of thousands of new, dangerous fragments. Plus, there's just simple shedding material flaking off spacecraft because of the extreme temperatures and radiation, like those paint flecks we talk about. It all adds up.
That paint flick example, you mentioned one hit the ISS window. That wasn't just theoretical.
Oh no, that was very real. Happened in 2016. One of those tiny flecks, probably paint or maybe a tiny metal fragment, hit one of the ISS's cupola windows. It gouged out a dent about a quarter-inch wide in the multi-layered glass. Luckily, the window is incredibly thick and strong, so they held. But it's a stark reminder, you know?
Definitely. A quarter-inch dent from a paint flick. It really drives home the danger. This sounds like a problem that could just snowball, right?
Right.
Could it get so bad that space itself becomes unusable in certain areas?
That is precisely the nightmare scenario.
Okay.
And it has a name, the Kessler Syndrome. It was proposed way back in 1978 by a NASA scientist, Donald Kessler. His theory was essentially that if the density of objects in low Earth orbit LEO gets high enough, you could trigger a chain reaction.
A chain reaction? Like dominoes.
It's exactly like dominoes. One collision creates more debris. That debris then hits other objects, creating even more debris. This cascading effect increases the probability of future collisions exponentially, potentially making certain orbital altitudes completely unusable for decades, maybe even centuries. It's a huge concern for the long-term sustainability of space activities.
So this isn't just about, like, losing one satellite here or there. This could actually lock us out of using space if it gets bad enough. And what about right now? How much of a threat is this to the missions we currently have up there? Like, the astronauts on the space station.
Oh, it's a very real and present danger. Space junk is already a significant threat to all functioning satellites, not just communications and weather ones, but scientific ones too. And absolutely to the International Space Station and the crews living aboard. Just look at the ISS. Since 1999, it's had to perform debris avoidance maneuvers, basically dodging out of the way, 25 times.
25 times, just to avoid getting hit by junk.
That's right. And sometimes with very little warning.
Incredible. And we've seen actual collisions happen too, right? Not just near misses. Big ones.
Yes, unfortunately. There have been several notable ones. Probably the most famous was February 10th, 2009. A defunct Russian military satellite, Cosmos 2251, slammed into a functioning U.S. commercial satellite, Iridium 33. That one collision instantly created over 2,300 pieces of trackable debris and likely countless smaller bits.
Wow.
Then, more recently, March 2021, a piece from an old Russian rocket apparently hit and destroyed a Chinese military satellite, Yunhai 102. And in June 2021, something hit the station's robotic arm, Canadarm2. They never even identified what it was, just space junk. Caused noticeable damage.
It definitely feels like we're hearing about these incidents more often. Is that backed up by data? Is the problem genuinely accelerating?
Unfortunately, yes. That 2020 report from ESA highlighted some pretty worrying trends. The sheer total cross-sectional area of objects in space, basically, how much stuff is up there, is steadily increasing. And that directly increases the chance of collisions. Here's where it gets really interesting, or maybe alarming. They predict that collisions are actually on track to overtake those accidental explosions as the main source of new debris.
So the Kessler Syndrome isn't just a theory anymore. It's something we're actively moving towards.
We're certainly seeing the conditions for it become more favorable, yes, especially in certain regions.
Which brings us back to low Earth orbit, right? That zone from about 100 up to maybe 1,200 miles altitude, that seems to be the real bottleneck.
Absolutely. LEO is critical for so many things: Earth observation, communication, constellations, the ISS itself. And yet, as NASA puts it, it's increasingly becoming a man-made junkyard. We estimate there are millions of pieces of human debris just in LEO, including roughly 36,000 chunks larger than that 10-centimeter softball size, all zipping around at those insane speeds.
Okay, so everything we've talked about so far is the danger up there. But you started us off with that story about the house in Florida. So what goes up? Does it always come down? What are the risks for us down here on the ground?
That's the other side of the coin, definitely. And yes, what goes up generally must come down eventually. Atmospheric drag, even way up high, slowly pulls objects back towards Earth. Now, on average, somewhere between 200 and 400 pieces of tracked space debris, the bigger stuff, re-enter Earth's atmosphere every year.
200 to 400 pieces a year. That sounds like a lot.
It does, but it's important to put it in context. Compare that to natural stuff. About 48.5 tons of natural meteoric material hits Earth every single day, mostly tiny dust particles. And the vast majority of that, maybe 95%, burns up completely in the atmosphere. We see it as shooting stars. And similarly, most man-made space junk also burns up on re-entry. Or, if it survives, it splashes down harmlessly in the ocean. And remember, Earth's surface is over 70% water.
Okay, so most of it burns up or hits water, but not all of it.
Not all of it. Larger objects or pieces made of very tough, heat-resistant materials like titanium or stainless steel, They can survive the fiery plunge through the atmosphere.
And we have actual examples of this happening, right? Not just the Florida house. Things have landed before.
Oh, absolutely. There's a history here. Probably the most famous early example was Skylab. NASA's first space station launched in '73 is huge, 100 tons. Its orbit decayed, and when it came down in 1979, a bit earlier than expected, actually large sections survived re-entry and scattered across parts of Western Australia. Luckily, no one was hurt.
100 tons.
Yeah. And more recently, we've had some pretty dramatic finds. There was that incident in Mukuku Village, Kenya. They found this huge 1,000-pound, 10-foot-wide titanium ring still smoldering in a field. Came from a rocket stage, probably. Then in August 2022, a farmer in Australia found this big charred chunk of metal on his sheep farm. Turned out to be part of the SpaceX Crew Dragon trunk section.
Right, I remember hearing about that. And there were others.
Yes. Just this past May 2024, another large piece, likely from a SpaceX Dragon, landed near a campground in North Carolina. And another piece turned up on a farmer's field in Saskatchewan, Canada.
And then the Florida incident, March 8th, 2024, that piece from the ISS cargo pallet. And that family, they're actually suing NASA now, aren't they?
They are indeed, seeking damages for the significant disruption and cost. And it highlights that the frequency seems to be increasing. A report in Nature, predicted for 2025, noted that large reentries are happening almost weekly now. And the number of trackable objects, the potential sources for this stuff, has more than doubled just in the last decade.
Weekly? Wow.
And beyond just the impact risk, there are emerging concerns. Some studies are starting to suggest that as more stuff deorbits, especially large constellations, the metals burning up high in the atmosphere, aluminum oxides, things like that, could potentially pollute the upper atmosphere or even affect the ozone layer.
So another environmental concern, essentially.
Potentially, yes. It needs more research, but it's on the radar. So while the actual statistical likelihood of someone getting hit by falling space debris is still very low, estimates put it around 1 in 10,000 chance of a casualty over a decade. These near misses, like the Florida house, are becoming noticeably more common.
Okay, so it's a serious problem both up there and down here, but surely people are working on this. It's not like it's being completely ignored. What kinds of rules or guidelines are actually in place? And maybe more importantly, are they working?
That's the critical question, isn't it? And yes, there are international guidelines and standards. They've been developed over the years, largely through bodies like the Interagency Space Debris Coordination Committee, the IEDC, and through the UN. These guidelines cover a few key areas. Designing spacecraft and rockets to minimize shedding, bits falling off during launch or operation. A big one is preventing those accidental explosions by passivating spacecraft at the end of their mission. That means venting leftover fuel, discharging batteries, basically making them inert so they don't blow up later. Then there's the end-of-life disposal, moving defunct satellites out of the way, either deorbiting them so they burn up safely over the ocean or boosting them into a higher graveyard orbit, well clear of the busy operational zones. And of course, performing those collision avoidance maneuvers we talked about for active satellites.
That all sounds sensible. But guidelines are one thing, following them is another. Are we actually seeing companies and countries making an effort? Are there any sort of glimmers of hope?
There are some positive signs, yes, definitely. But progress is, well, it's mixed and maybe slower than we'd like. If you look at low Earth orbit, for satellites launched into orbits that don't naturally decay within 25 years, which is the general guideline, maybe 15 to 30% have attempted some kind of mitigation, like moving to a disposal orbit. And the success rate for those attempts is somewhere between 5 and 20%, although there was a peak around 35% success in 2018, largely thanks to the Iridium constellation being actively deorbited.
Okay, so not amazing numbers for satellites and LEO. What about rockets? You said they're some of the biggest pieces.
Rockets are actually a slightly better story. About 80% of rocket bodies launched now attempt to clear LEO after deploying their payload. That's a huge improvement from maybe only 20% back at the start of the millennium. Now, the success rate for those attempts is still variable, maybe 30 to 70% manage it successfully. But getting those massive rocket stages out of the way is really significant.
That is a big jump. 80% attempting is much better.
It is. And there's another factor. For small satellites launched into very low orbits, say below 600 kilometers, around 88% naturally comply with the 25-year deorbit rule. Just because atmospheric drag is much stronger down there, they re-enter relatively quickly on their own.
Ah, okay. So altitude makes a big difference naturally.
It does. And then if you look way higher, out in geostationary orbit where those big communication and weather satellites sit, The adherence rates are actually very high. We see 85 to 100% attempting disposal maneuvers and 60 to 90% succeeding.
Why so much better out there?
Well, it's valuable real estate. Operators have a strong commercial interest in keeping those orbital slots clear for future satellites.
Yeah.
So there's a powerful incentive to follow the rules.
Right, makes sense. So there's effort, there are guidelines, but what about all the junk that's already up there from decades past? Or the satellites that just fail? They break down, lose contact, and can't be moved? Are they just stuck there forever?
That's a really important point. Passive mitigation, designing things better and following end-of-life rules is crucial, but it doesn't address the existing debris population. And yeah, the UN guideline asks operators to deorbit satellites within 25 years, but what if the satellite dies unexpectedly after only 5 years? You can't command it anymore. Enforcement is really tricky. So this has led to a whole new field, active debris removal, or ADR. People are developing some seriously innovative, almost sci-fi technologies to go up and actively capture or deorbit existing junk.
Okay, now this sounds interesting. What kind of things are we talking about?
All sorts. There are concepts for harpoons, literally firing a harpoon into a dead satellite to grab it.
No way, harpoons in space.
Yep. Huge nets to capture debris. The UK actually tested one with the Remove Debris mission back in 2018, launched by Surrey Satellite Technology. It successfully netted a target. People are looking at using powerful magnets to grab onto certain types of debris, even using ground-based or space-based lasers.
Lasers? How would that work? To blow it up?
No, not to destroy it. That would just create more small debris.
Yeah.
The idea is to gently heat one side of the object with the laser. This causes material to ablate or boil off slightly, creating a tiny bit of thrust. Or, alternatively, the laser slightly changes the object's surface properties, increasing its interaction with the very thin atmosphere, enhancing drag. Either way, the goal is to nudge it into a lower orbit so it burns up faster.
Wow. Harpoons, nets, lasers. It really is like something out of a movie. But looking ahead, despite these cool technologies, is there anything coming down the pipeline that could make the whole problem even worse?
Unfortunately, yes. The elephant in the room right now is the rise of the mega constellations.
You mean like SpaceX's Starlink?
Exactly. Starlink, Amazon's Project Kuiper, OneWeb, and others potentially planned. We're talking about adding tens of thousands, maybe 50,000 or more additional satellites into low Earth orbit in the coming years. Now, the operators are designing them with deorbit capabilities and plan to adhere to guidelines, but the sheer number is the issue. It just dramatically increases the density of objects, meaning collision risks go up, and the number of avoidance maneuvers needed will skyrocket. ESA had to perform its very first maneuver to dodge a Starlink satellite back in September 2019. It's a huge operational challenge.
50,000 more satellites. Yeah, that does sound like a recipe for more cosmic traffic jams, even if everyone tries to follow the rules. So when we take a step back, what's the bigger picture here? What does this whole space junk saga tell us about how we're approaching space?
I think the most crucial point, something ESA really emphasizes, is that we must start thinking of the space environment, especially these useful orbits around Earth, as a shared, finite, natural resource. It's not just an infinite void we can dump stuff into. It's a vital resource that enables so much of modern life communication, navigation, weather forecasting, climate monitoring, scientific discovery. Preserving it is absolutely essential if we want to keep benefiting from all that. And, maybe it forces us to confront a difficult question.
Which is who?
Have we, as a species, just kind of exported our bad habits from Earth, our patterns of consumption, waste generation, and not thinking about long-term consequences?
Yeah.
Have we just taken those straight into orbit, this new frontier?
That's a really sobering thought, but it is encouraging, I guess, that organizations like the European Space Agency are actively working on this. You mentioned they support the UN guidelines.
They do. They're also funding the world's first mission, specifically designed to remove an existing piece of debris, the ClearSpace 1 mission, targeting an old Vespa rocket adapter. And they're investing heavily in developing technologies for automated collision avoidance systems, because the number of potential collisions is becoming too high for humans to manage manually.
Okay, so active efforts are underway. But hey, here's a slightly weird tangent for you, just popped into my head. We're talking about cleaning up Earth orbit. Have we left junk anywhere else? Like the moon?
Oh, absolutely. It's not just Earth orbit we've littered. The moon has its own collection of human artifacts, or junk, depending on your perspective.
Really? Like what?
Well, we left behind the 3 lunar roving vehicles, the moon buggies from the Apollo missions. They're still up there. Plus debris from at least 54 uncrewed probes that either landed or crashed. Altogether, estimates suggest there's around 190,000 kilograms, that's over 400,000 pounds of human-made material scattered across the moon.
Wow. Any particularly weird stuff?
Oh, yeah. There's a small golden olive branch left by Apollo 11 as a symbol of peace. There's apparently a tiny ceramic tile with art by Andy Warhol, among others, smuggled up on Apollo 12. Alan Shepard famously hit 3 golf balls on Apollo 14. There's a falcon feather drop during a science demonstration on Apollo 15. And astronaut Charles Duke left a framed photograph of his family on the lunar surface.
Golf balls in a family photo. That's amazing. So our interplanetary cleanup might eventually need to extend beyond Earth orbit. All right, so wrapping this up. As you look up at the sky tonight, maybe think about this. It's a bit of a mixed picture up there. We've got these worrying trends for sure. More stuff, more potential for collisions, actual debris falling back to Earth, this growing orbital junkyard. But on the other hand, there are also these glimmers of hope, increasing awareness, international guidelines getting some traction, and these really quite ingenious technologies being developed for active cleanup. Cautious optimism, maybe.
I think that's fair. Cautious optimism. But it hinges on sustained effort. Continued investment in developing and deploying these cleanup technologies is crucial. And perhaps even more importantly, we need much better, more consistent adherence to the existing mitigation guidelines by everyone operating in space. Governments, commercial companies, everyone. This isn't just about protecting expensive satellites anymore. It's really about learning to manage a shared environment responsibly, a lesson we're still struggling with down here on Earth, aren't we? So maybe the final thought for you to ponder is this. What responsibility do we truly have as a species for managing this new frontier? How do we ensure it remains safe and usable for generations to come? And does our behavior in space just hold up a mirror to how we treat our own planet? It's definitely something worth thinking about.